Hello there guys. In this session, we will discuss about redundant link in a mechanism.
Let's begin.
In a mechanism, a link is redundant if its presence or absence does not affect the nature of the mechanism. That is, even if we remove that link, the mechanism will behave in the same manner.
Can such a situation really occur?
For example, consider this mechanism. The three binary links are equal in length and are parallel to each other. Both the ternary links are also equal in length and parallel to each other. Owing to its unique geometry, this mechanism has 1 degree of freedom. Now, if we remove any one of the binary links of this mechanism, as shown, it does not affect the nature of the mechanism. So, we see, any one of the three binary links in this mechanism is a redundant link.
I understood that. So, this implies that the presence or absence of the redundant link won't affect the degree of freedom of the mechanism.
Correct, but one needs to be cautious while calculating the degree of freedom of such mechanisms using Grubler equation.
But, why is it so?
Let's calculate the degree of freedom of this mechanism using Grubler equation. According to it, degree of freedom of a planar mechanism, M, equals 3 times L minus 1, minus 2 times J1, minus J2, where M is the degree of freedom or mobility of the planar mechanism. L is the number of links in the planar mechanism. J1 is the number of joints having 1 degree of freedom. J2 is the number of joints having 2 degrees of freedom. Now, can you tell the number of links in this mechanism?
Yes, there are 5 links of which 3 are binary and the remaining 2 are ternary links.
Correct. And what's the number of joints having 1 degree of freedom?
All the joints in this mechanism are revolute joints. So, there are 6 joints having 1 degree of freedom.
Correct. And what's the number of joints having 2 degrees of freedom?
There is no joint having 2 degrees of freedom.
Correct. So, the degree of freedom for this mechanism computes to 0.
But, that's not true. The degree of freedom for this mechanism is 1 in actuality.
Correct. This inconsistency in the result is caused by the presence of redundant links in the mechanism.
Then, how should we calculate the degree of freedom for such mechanisms?
For that, before using the Grubler equation, you need to remove the redundant links from the mechanism.
You mean, we need to remove any one of the binary links from this mechanism, and then use the Grubler equation?
Correct. Let's remove the yellow link and calculate the degree of freedom. Now, the number of links in this mechanism is 4. The number of joints having 1 degree of freedom equals 4. And there are no links having 2 degrees of freedom. Hence, the degree of freedom computes to 1, which is in agreement with the actual degree of freedom for this mechanism.
Exactly.
Now, here is a challenge for you. Try to identify the redundant links in this mechanism, if there is any. You may pause the video while you think.
This mechanism is very similar to the one we discussed. Clearly, any 2 of the 4 binary links in this mechanism are redundant links.
Correct. This mechanism too has 1 degree of freedom as discussed in the video. Now try this. Calculate the degree of freedom of this mechanism without removing any of the redundant links. After that, calculate the degree of freedom of this mechanism after removing the redundant links, and hence, verify that it is equal to 1, which is the actual degree of freedom of this mechanism. This is for now. Hope you enjoyed this session. You may also like to watch these videos